Hey guys, in this video we're going to look at the free response question number 4 from the 2010 AP exam. So in this question we're looking at an automobile company that's trying to learn more about their customer satisfaction, and what happens is they collect data over 6 months and they break it down by the model of cars. So we have 5 different models given total. Now within this population we have 3 parts to the question. For the first part, we were trying to see if we had a simple random sample of 2,000 new car owners, what the expected number of owners of Model E and the standard deviation of that same model would be. For part B, when we're selecting a simple random sample of 2,000 new car owners, we want to know how likely it is that fewer than 12 owners of Model E would be included in the sample. And for part C, the company is concerned that a simple random sample of 2,000 owners would include fewer than 12 for both D and E. And we briefly want to describe a sampling model that could randomly select those 2,000 and ensure we would still have at least 12 from both categories. So first, let's really break down the intent of this question. We see that it's got 3 parts, A, B, and C. And that's how our grading was broken up for this question. So College Board gave out that the intent of the question was 1, to assess the student's ability to calculate an expected value and a standard deviation. So that's a little bit straightforward from part A there. 2, recognize the applicability of a binomial distribution and perform a relevant binomial probability calculation, or recognize that the applicability of a normal approximation can be used to perform a relevant probability calculation. So that was really what they saw in part B. And for part C, this third piece was brought up to suggest an appropriate sampling method to achieve a given goal. So College Board also gave out their answer key. So if we look at that part A, what you should notice is that we have a particularly large sample size. So we have the whole population of the 6 months for this particular car company. And really, because it's so large and we have a sample size of 2,000 here, we can use a binomial distribution. So right off the bat, we can find what P is by taking the total of E and dividing it by the total of all cars. So we get our probability there. Now remember, the expected value is N times P, which is just the sample size times that probability. So we first calculated the probability, and then we multiply that by 2,000. So we should have gotten 15.62. And if you would have had 15.6, or even if you rounded up to 16, you'd be okay in that place. Now, the last part was calculating the standard deviation, which is the formula of the square root of the variance, or the square root of NPQ. So remember, P is the probability of success, and then Q is the probability of everything else, the failure. So we would have multiplied those 3 things together under the radical and gotten 3.94. And again, if you had 3.9 or a little slightly different there, it would have still been okay. For part B, there was a couple different things you could have done. Now, a lot of you I saw ended up relating it back to a normal calculation, which is great. So that would have been this part down in the bottom here. So with that being said, the binomial probability can be used. You can use a normal approximation because it's large enough. Remember, we still want to check that NP here. We use that and we calculate that 15.6 is greater than or equal to 10. And then we check the failure. Remember, this is the success failure condition or the large enough condition. But once you check both of those, we know that it's large enough and we could proceed with a normal calculation here. Now, in this particular rubric, they didn't stress so much that you had to show the large enough, but keep in mind that this test was from 2010, so we're talking 10 years ago. The requirements have gotten a little stricter as we've moved forward, so I wouldn't be surprised if a question similar to this came up, that they would dock you points for not showing that. So keep that in mind as we are doing these tests and we keep practicing that we sometimes have to be a little bit more specific than the given rubric. But from there, I would have done the calculation of showing my normal model. I would have drawn a picture and shaded it in. We would have had 15.62 was our mean. We wanted shade to the left because we were looking for when it was less than 12. and we would have had that all in there too. And I'll show you an example of student work that has that. The other thing you could have done was use the binomial distribution. So that we're talking about our normal CDF, or excuse me, our binomial CDF. Remember, we have binomial because it's out of a given amount, CDF because it's cumulative. You're like starting with 0 and you're going up to 11. Notice we're not going up to 12 because it was less than 12 that we were trying to look for. So in this notation, they show you from 0 to 11. You could have also wrote it out with our 2000 choose 0 and then filled it in and then like plus ... till we got to 2000 choose 11 with success to the power and gone from there. And finally, for part C, this was going to be, we're looking for stratified random sampling here. So there was 3 big things they wanted us to talk about with this stratified data. Remember, you want to talk about it being random. Anytime you're collecting data, we want to make sure we're talking about random. They give you an example of how you can break up each of these samples to make sure we have it. So you could have done by proportion and made it so that it was in the same proportion as the totals that we were given from the problem. But really, as long as it says some kind of mention of random, at least 12 owners from each population, and that it had a total sample of 2,000, those were the 3 big things that they instructed the graders to look for. So there's a couple big ideas that we kind of want to remember from this question. First, binomial is used when there's a fixed total. So we knew this sample was out of 2,000, right? So we knew it was going to be binomial. And also we use binomial CDF because it's cumulative data. We're going from 0 up to 11 because we wanted all the values that could potentially be less than 12. An expected value, we calculated this, in this case, n times p. The variance would be npq, and then the standard deviation is npq all under the radical. We also have our large enough condition, which also can be known as a success-failure condition, and we can assume that this is approximately normal. So that would have been one way to solve the problem. And then finally, stratified sampling is when we slice the population into homogeneous groups, known as strata, to represent every subset of the population. So you might remember back when we first introduced this topic, we talked about a Boston cream pie, because that's broken up into layers, right? You have like your cake, you have the cream, like the filling and the dress, or the icing, excuse me. But each of those layers, we want to represent it. So we want to make sure we're taking a random sample from each type to make sure we're getting accurate data like that reflects each part of it. So in this case, our strata would have been each model type and making sure we collected data from each one. So let's kind of look at their scoring outline here. So A, B, and C were the parts that were all going to be individually scored for the EPI rating. So for part A, to be essentially correct, you would have had to show the calculation for the expected number of owners for model E and the standard deviation. So as long as you showed them both correct, you would have gotten an E here. Partially correct would have been if you got one of the two, or what was nice too, they even said that if you showed both of the correct formulas and then made a mistake with the numerical value. So if you would have wrote down both your formulas, you could have pulled off a P as well. And then incorrect would be only one without showing how they were calculated. For part B, to be essentially correct, you needed to either recognize the applicability of the binomial distribution, identify the correct parameters, set up the relevant probability calculation, and complete the calculation correctly. Okay, so what I mean by that is you could specify what each part of the binomial CDF is when you're being careful, like writing out what you know for each component of what you're plugging into the calculator, or you could show the work of 2,000 choose 0 with your probability of success raised to the 0, and then like your probability of failure raised to the 2,000, and then you show you're adding. Remember, you don't have to write out all 12 of them. you can just do the dot, dot, dot in between. So have like your first, second, and your last, just so you're showing work that you understand what it means. You could have also done the normal model approximation, which identifies the relevant mean, the standard deviation, and shows the correct calculation of the probability. So you want to make sure you're specifying all of those pieces and using the normal model appropriately. Or you provide an argument based off the appropriate z-score and the number of standard deviations away from the mean. Partially correct in this case would recognize the applicability of the binomial distribution and identify the correct parameters, but you might set up the cumulative, have a error when you were setting up this cumulative probability. Okay. Same thing with the binomial, it's just that you correctly set it up, but you do not correctly identify the parameters. So this is you trying to plug it into the calculator, but not specifying what each piece means. And then recognizing the applicability of the normal approximation, correct parameters, but incorrectly calculate the z-score of the probability. Okay. And then there were some notes down here as well that you can look through just to see if any of those mistakes kind of correlated to something you did, but they just kind of kept some things there for the graders. While Part C, we talked about it, it had 3 big things to be essential. So total sample size of 2,000, at least 12 owners for each of the 5 car models, and random. So if you had all 3, you would have gotten an E. If you have 2 out of the 3, you'll get a partial, and then if you only have 1 or none, you would have gotten an I. So then we have the rubric here. All 3 essential parts would have gotten a 4. 2 essential parts and 1 partial would have gotten you 3. And then there's 3 different scenarios that would have gotten you a 2. And then 2 different scenarios that would have gotten you a 1. And we'll look through that with the student work that I'm going to show you next. So here we have student A. You'll see that they first correctly calculated the probability and then got the expected value by showing 2,000 times the probability. They got that 15.62. Great. They wrote it out as NP and then 1 minus P. That's the same as NPQ. We show the calculation for it and the standard deviation. Both parts are there correctly with the work shown. That got an E. Now you'll see this student here also. Notice that it was a normal model, or it could be approximately normal here. So the z-score is calculated with 12, the value we're looking at, subtract the mean, which is our expected value, over the standard deviation, and then made a probability statement of z being less than negative 0.919, and they calculated their data that way. Correct shading, you have the standard deviation and the mean from the previous part, so they didn't really take off any points by not labeling the picture. I would, just to make sure you're doing as best you can, as most as you can. Also, I would have felt more comfortable if they attached in the large enough feature here. They weren't as strict, but you never know if they're going to be in the future. And in this part C, all 3 parts are covered. So they mentioned stratified random sample. They show what each group is going to break down to. So you're randomly picking from A, randomly picking 646 from B. All of these pieces broke down. So we have the random mention. And notice they're picking that so it's in the same proportion as the values that they had in the beginning. So it definitely is at least 12 from each. It says random. And if you add up all those values, it gets you a total of 2,000. So it covers all 3 pieces there. So I don't really have to go into this too much, but we see that all 3 are essential. So we would have gotten a 4. Or that student did get a 4. This one, student B here, they showed a correct calculation for finding the expected value, but used a standard deviation for a sample proportion. So that knocked them down to a P. But for part B there, even they're doing a binomial setting, and they indicate what each piece of the binomial CDF is. They talk about all these pieces, a really well descriptive piece, so they still got essential there. And if you separated the list of the new cars by the model and then you randomly choose 400 owners from each of the group, then guarantee that 400 owners of each of the different models. So we know 2,000 total. It says random. It has at least 12 from each. So we got an E. So we're looking at an EPE here. So that would have been 3.